Assalamualaikum warahmatullahi wabarakatuh. Good morning to all my students. Okay, so today we are going to get into new topic of our syllabus for this semester for matrices and linear equation, system of linear equations, 4.1 matrices. Okay, so before I continue my teaching, so I do hope that all of you willing to support my channel by click on like, share, and subscribe, and also bell notification button so you may get the latest or next videos of my channel. Okay, so without wasting so much time, let's continue, and I do hope that all of you holding your lecture notes with you right now. And for matrices, at the end of this topic, students should be able to identify the different type of matrices. Okay, different type is based on the size of the matrices. Okay, the size is come up with m, the size of m multiplied with n. Okay, perform the operations on matrices and define the transpose of a matrix and use the properties. So then, okay, a matrix is a rectangular array of numbers enclosed between brackets. So then the general form of matrix with the m rows and n columns. Okay, so this we call this a row and column. Row 1, row 2, row 3 until row of this is a column of 1, 2, 3 until a column of n, and this is a row. Sorry. This is a row 1, row 2, row 3. Okay, and a column. Oh, sorry. I think that is make a mistake here just now. Okay, I'm confused. This is a column, and this is a row. Row 1, row 2, row 3 until row of m, and column of 1, column 2, column 3 until a column of n. Sorry for the mistake just now. Okay, m rows. Okay, row 1, row 2 until row of m, and then n column. Okay, column number 1, column 2, column 3 until a column of n. Or in a compact form, A is ij. Okay, so then the element of A12, row number 1, okay, row number 1 and column number 2, which is 3, and A22, the element of A, row number 2 and column 2, row number 2 and column 2, they make here, which is equal to 8. The order of dimension of matrix m rows and column is m times n. Okay, this one here, row 1, row 2, and column 1. So 2 times 1. And this one is row 1, row 2, column 1, and column 2. Okay, I'm not going to explain everything here. You may just read and it's understood, because the explanation is very simple here. Okay, so the column matrix of m times 1, row 1, row 2 with 1 column only, and also 1 column. Okay, square matrix. Square matrix means that if a matrix of m times n, in this case, whether m is equal to n, the size are equal. Okay, we got row 1 and row 2, then also here column 1 and column 2, 2 times 2. And this is a column of matrix of 3 times 3. A zero matrix, which every entry is 0 and denoted by matrix of 0 here. Okay, simple. That's what we call a zero matrix. Diagonal matrix It's a square matrix where all the elements are 0 except those in leading diagonal. Leading diagonal here. Okay, diagonal matrix. Example here, and here you can see there are upper triangle zeros and lower triangle zeros, and the rest is a diagonal with an element which is not 0. Identity matrix. Okay, so the diagonal from here with all 1 and the rest is zeros. Lower triangle matrices, as you can see here now, the lower triangle matrix here, which element is not a 0, and the rest above here is 0. Upper triangle, okay, of course, an opposite, something like that. Okay. Operation of matrices. Addition or subtraction of two matrices only defined when they have the same order. Same order means that, okay, we're going to look at here. Okay, example A, B. So the same order means that, for example, let's take a look at the matrix of A. This is we call a matrix of, okay, row 1, row 2, column 1 and column 2 is a matrix of 2 times 2, and also here clearly is exactly the same as the A here, which is a matrix of 2 times 2. So then for addition and subtraction with the same order, meaning the size are equal for both of A and B. Okay, so find A plus B. So for A plus B, I just make it here. Okay, equal to matrix of 1, 2, 3, 4 plus with 4, 3, negative 5, 6. Okay, so then 1 plus 4, 5. 2 plus 3, 5. 3 plus negative 5 or 3 minus 5. 3 plus negative 5, 3 minus 5. Negative 2, and 4 plus 6 equal to 10. Okay. What about B just now? B is, okay, B minus A. 4, 3, negative 5, 6. Minus A. 1, 2, 3, 4. Okay. So 4 minus 1, 4 minus 1, 3 minus 2, negative 5 minus 3, and 6 minus 4. So 4 minus 1 equal to 3, negative 5 minus 3, negative 8, 3 minus 2 equal to 1, 6 minus 4 equal to 2. Okay, this step. Okay, this step that you should also write for a question of A just now, A plus B. I forget this part. Okay, and forget this part that we should also show here. Okay, you may add add or we call make some correction or fix that. Okay, never mind. I rewrite here. So this one here. Equal to, okay, 1 plus 4, 1 plus 4, 2 plus 3, 3 plus negative 5, and 4 plus 6. Okay, so then it's come out with 1 plus 4 is 5, 2 plus 3 is 5, 3 plus negative 5, positive, negative, negative 3 minus 5, negative 2, 4 plus 6, 10. Okay, B minus A, I showed you just now. at the question then. So you may just refer to that. Scalar multiplication, C is a scalar and A equal to a matrix of Aij, then it's multiplied in here. Okay, then A equal B, find 3A minus 2B. Meaning 3 multiplied with the matrix of A, 1, 2, 3, 4, minus 2 times matrix of B, 4, 3, negative 5, 6. Okay, so now 3 times 1 equal to 3. 3 times 2, 6. 3 times 3, 9. 3 times 4, 12. Minus 2 times 4, 8. 2 times 3, 6. 2 times negative 5. 2 times negative 5, negative 10. And 2 times 6 equal to 12. Okay, we leave the negative first. Okay, we multiply 2 with every single element that we have in B. Okay, now 3 minus 8, 6 minus 6, 9 minus negative 10. Okay, and 12 minus 12. Okay, negative 2 times 6, negative 12. So 3 times 4, 12. 12 minus 12. Okay, so then here it is 3 minus 8, negative 5. 6 minus 6, 0. Negative, negative become positive. So 9 plus 10, 19. 12 minus 12, 0. So then, these are the properties, or we call the rules that we're going to use, okay, for this topic. Okay, never mind. We're going to discuss all this with examples so you can see clearly. Multiplication of matrices defined only when the number of columns in A is equal to the numbers of rows in B. Okay. Class. If order of A is n times n and B is n times P, then AB, okay, it's just like this. The matrix of A with the order of n times n multiplied with matrix of B with n times P. N is the size of row and n size of column. For this B, n is size of row and P is the size of column. So look at this one here now. Here, they are equal. Okay. Then it will give us the new matrices of C. Okay, the matrices of C with the size of M and P. Okay. That's it. Okay. You may refer to your lecture notes. It's all the same then. Okay, number must be equal, and you can here. For example, if a matrices of 3 times 2 multiplied with the matrices of B 2 times 4. Okay, the size of matrices of this column and this row are equal. So it gives us the matrices of a new matrix of C or AB. Just name it. Okay, C with the size of 3 times 4. Okay, let's take a look at this one. A row and a column must have the same order or of entries in order to be multiplied. Okay, multiplication of two matrices. Example, find AB. Solution. Okay, AB. And please name it. What is the size of this matrix of A? Yes, there's only one row. 1 times, how many columns do we have? 1, 2, 3. Okay, the size is 1 times 3. Now, what is the size of B now? How many rows do we have? 1, 2, 3. And then the column is only 1. So the size of column and row for matrix of B, because it's A multiplied with B here. If B multiplied with A, how about it? Is it possible? Okay, you try by yourself. Okay, for this one here, then finally it will give you a matrices of 1 times 1. Okay, so then 2, 5, 1 multiplied with 0, 3, 2. Okay, so then 2 times 5, 2 times 0 equal to 0, plus with 5 times 3 equal to 15, and 1 times 2 equal to 2. So then 0 plus 5 plus 2 equal to 17. This is 1 times 1, right? Look at this one here now. It's a 1 row and 1 column. A matrices of 1 times 1. Okay. Find A squared. So then A squared means that matrix of A multiplied with matrix of A. Okay. 1, 2, 3, 4. Multiplied with 1, 2, 3, 4. Okay, so slowly, one by one. 1 multiplied with 1. Okay, 1 multiplied with 1 plus with 2 times 3. Okay, that is the first one. Sorry. Then 1 multiplied with 2. 1 times 2 plus with 2 times 4. Okay. Next, we complete the first row 1 and 2. 1 and 2 multiplied with the first column here 1 and 3 and 2 and 4. 1 times 1, 2 times 3. Element in row 1 multiplied with element in column 1 here. And element in row 1 multiplied with every element in column 2. There you go. Now it's time for row number 2, 3 and 4. Okay, so 3 times 1 plus with 4 times 3. Okay. Okay, then element in row 2, 3 and 4 multiplied with element in column 2, 2 and 4. So 3 times 2 plus with 4 times 4. There you go. So then it's time for us to multiply and add everything here. So 1 times 1 equal to 1, 2 times 3 equal to 6, 1 times 2 equal to 2, 2 times 4 equal to 8, 3 times 1 equal to 3, 4 times 3 equal to 12, 3 times 2 equal to 6, 4 times 4 equal to 16. Okay, so then now we are going to add everything here. 1 plus 6, 7, 2 plus 8, 10, 3 plus 12, 15, 6 plus 16, 22. There you go. Okay, so what about this one here now? Find AB. So A multiplied with B for this one here now. negative 1, 2, 1, 3, 4, 5, 2, 3, 1. And also B here, 2, negative 1, 2, 3, 2, 1, 1, 4, negative 1. Okay, now, element in row 1, negative 1, 2, 1. Firstly, we're going to multiply with element in column 1, 2, 3, 1. So then negative 1 multiply with 2 plus with 2 times 3 plus with 1 multiply with 1. Okay, so element in row 1 has already complete multiply with element in column 1. Now element in row 1 multiply with element in column 2. Negative 1 times negative 1. Okay, then 2 times 2. And 1 times 4. Okay. Then element in row 1 multiply with element in column 3. So that you get negative 1 multiply with 2. Okay, 2 times 1. And 1 times negative 1. Okay, I can't see it. I'll make some changes here, sorry. Okay, I rewrite everything. Okay, first one here, negative 1 multiply with 2 plus 2 times 3 plus with 1 and 1. Then negative 1 to 1, negative 1 times negative 1 plus 2 times 2 plus with 1 times 4. Then negative 1 to 1 with 2, 1, negative 1. So negative 1 times 2 plus with 2 times 1 plus with 1 times negative 1. There you go. Now, element in row 2, we're going to multiply 1 by 1. Firstly with element in column 1, then next with column 2, then next with column 3. So 3, 4, 5 element in row 2 multiplied 1 by 1. So here now 3 times 2 plus with 4 times 2, 3, 1. So 3 times 1, 3 times 2, 4 times 3, 5 times 1. 4 times 3 plus 5 times 1. Okay, and then 3 times negative 1 plus 4. 3 times negative 1, 4 plus 2 plus with 5 with 4. Next, 3 with 2. Then 4 with 1. And 5 with negative 1. Next, okay, element in row 3 multiplied with every single element firstly in column 1, then next column 2, then next column 3. So 2 times 2, 3 times 3, and 1 times 1. Now, next, 2, 3, 1 with negative 1, 2, 4. 2 with negative 1 plus with 3 with 2 and then 1 times 4. Then next is 2, 3, 1 with 2, 1, negative 1. 2 times 2 plus with 3 times 1. Then 1 times negative 1. Okay, so then we are going to find the sum of every single element row that we have here. So negative 1 times 2 is negative 2. Okay, negative 2, 6, 1. So negative 2. Negative 2 plus 6, 4 plus 1 equal to 5. And then this is negative, this is 1. 4, 4. 1 plus 4 equal to 5. 5 plus 4 equal to 9. And then this is negative 2, 2, negative 1. Negative 2 plus 2 equal to 0, minus 1, negative 1. Okay. Now, 3 times 2 equal to 6. 4, 3, 12. 5, 1, 5. 6, 12, 18 plus 5, 23. Okay, I recall I count this randomly without using calculator. So please, if I make a mistake, you find a mistake, then let me know, or you may just make a correction on your lecture notes. Okay. 3 times 1, negative 3. 4 times 2, 8. 5 times 4, 20. 20 plus 8, 28 minus 3, 25. Okay. 3 times 2 equal to 6. 4. 5 minus times negative 1, negative 5. 6 plus 4, 10 minus 5 equal to 5. 2 times 2 equal to 4. 3 times 3 equal to 9 and 1. 4, 9, 13 plus 1 equal to 14. Negative 2. 6. 4. 6, 4, 10 minus 2 equal to 8. Okay. 4, 3, 1 with negative 1, negative 1. 4 plus 3 equal to 7, minus 1 equal to 6. There you go. Okay. But for this one, please, you need to be careful because sometimes you make a simple, silly mistake with a sign of negative and positive only, and we will spoil everything. Okay. Transpose A, written as A transpose, is a matrix obtained by interchanging between row and column. Okay. So this is a matrix of B. Okay. Row 1, row 2, and row 3. So 3 rows and 1 column. Then B transpose is transformed into a matrix of 1 times 3. Okay. What about this one here? D. Okay, look at this carefully. 1, 3, 3, 2, 5, 4, 1, 3, 5. Then matrix of D transpose. Look at element of row or of the column. Column 1, 1, 2, 2 has now become row 1, 2, 2. Element in column 2, 3, 5, 3 has now become element in row 2. This is column 2 and row 2. And element in row column 3 has now become element in row number 3. So the interchange between row and column, that's all. So then find C transpose times B transpose. Okay, so I just make on here. C transpose, okay, C transpose equal to, okay, C transpose for this is C, matrix of C, so C transpose equal to 1, 4, 3, 2. Okay. And then B transpose, this is a matrix of B, so B transpose, the element in row turn into column 3, 4, 2, 1. Okay, the rest as usual. Okay. So 1 times 3 equal to 3 plus 4, 3 times 4 equal to 12. 1 times 2 equal to 2 plus 3 times 1 equal to 3. 4 times 3 equal to 12. 2 times 4 equal to an 8. 4 times 2 equal to an 8. And 2 times 1 equal to 2. 3 plus 12, 15, 18, 12 plus 8, 20, 5, and 10. Okay. So these are properties of transpose that you need to remember that we're going to use sometimes, okay, for this topic. Okay, so these are conclusion for part 1 of lecture of topic 4. So I do hope that this video helps you, and you may just recall, complete or fill the examples in your lecture notes and start with your tutorial. And don't wait, recall, just don't wait. And once you get this video, once you've completed the notes, and just try the question of the tutorial and pass your questions. That's all. Thank you very much. Till we meet again. Assalamualaikum warahmatullahi wabarakatuh. Have a nice day.